Hello, welcome back to the next Gren Twigs video. It's been a while, but I'm back with another one. I am going to show you how to interact with standard IO and Gren. So that's like reading from standard in, sending things to standard out, might even involve standard error a little bit. Let's see, but we're going to start from scratch here with an empty directory and kick off a new node application. So that's Gren init, specifying node as the platform. That'll make our gren.json file for us, install the required dependencies, and we can start things off in a main file, as long as you spell correctly, which I can't do this morning. But I'm going to import some stuff I know I'm going to need. So to make a node application, we need the node module. We're going to interact with standard IO. So those are streams. We're going to need the stream module. This is going to be a full node application, which means we need to have the init module. We'll probably need more, but I can add it when I need it. So every node app needs a main function. Our main function is going to be a node program, or it's going to return a node program, which holds the model and message types, which we'll make soon. And to create a node program, you use define program in the node module, and it takes a record, which wants our init function, our update function, and our subscriptions function. Okay, let's make those functions. Let's start with init. Init will receive the environment, and it should return an init task, which will hold an instance of our model and a command to run when the program starts. So to get an init task, we can call start program. That also, similar to defined program, it takes a record, but we need to initialize our model. What is our model going to be? So we'll make it a type alias, and it can hold whatever sort of state we need for our running application. We're going to be interacting with standard IO, so let's hold references to those things. So we're going to want standard out, which will be a stream, a writable stream of bytes. So we're going to need that type imported as well. Okay, standard out is a writable stream of bytes. Standard in is a readable stream of bytes. Let's go ahead and grab standard error. We might use that. It's also a writable stream of bytes. Okay. So those are going to be in our environment. So we can say that standard out is the incoming standard out, and so on. All right. And our command, let's see, to start the program, for interacting with input and output, let's ask for your name, and then we will print back your name, like hello person. So to ask for the name, we need to send the message to standard out saying, hey, what's your name? So the way you do that is with the stream module. There's various functions in the stream module you can use. We're going to use write line as bytes. What that does is it lets us send a string to a stream, but since it's a byte stream, it'll automatically convert that string to bytes for us, and it will also send it as a line, meaning it'll add a new line for us as well. So we're gonna say, hey, what's your name? And we are sending that to standard out. Now this is a task, so to turn a task just describes something we want to do. It's not actually doing the thing yet. For it to do the thing, we need to, for Gren to do anything outside of your running program, like interacting with standard out, we need to send a command to the runtime. So to turn this task that this function gives us into a command, we can use the task module, which we need to import as well. Great. This task is one that can fail. So actually, I should be pulling up the docs so that you can see what I'm talking about here. Let me get that pulled up in another window, and then I'll drag it in. So zooming in a little bit. All right, here we go. So packages.grenlang.org. We've got the core package here is where our stream and our task modules live. So let's look at stream. Where are you, stream? Streams, there it is. Okay, so we did, working with writable strings here. So write lines bytes, here we go. So you can see it gives us a task. It's a task that can fail. There is an error type here. So it'll be a stream.error type. And it also returns the task that you just wrote to if it doesn't fail. So if we have a task that can fail and we want to turn it into a command, let's look at the task module. So perform takes a task that can't fail. We don't want that. Attempt lets us define an error type ourselves. So that's what we want. So we want to say task.attempt, and what does this want? It wants, it might be a little bit hard to read, but it's a function that takes a result type and returns a message. When you see something like this, where it's like takes something and returns a message, that's a message constructor. So our update function will be interacting with messages. So we're going to define that message type. So the task that we want to attempt, let's call it asked for name. And that constructor should be one that takes a result that can fail optionally, and some success type. So a result that can fail, the way this one's going to fail would be with a stream error, and if it succeeds, what did it do? It returned the same yeah, so it just returns the stream again. All right, so what this does is creates the task to describe this is what we want to do. We want to send this string to standard out. Go ahead and try to do that. Once you do that, send my update function a message, this message, ask for name. And you can call that with your result. So the result will either be, hey, this didn't work, the stream was closed, there's no standard out for whatever reason, I'll get an error, or hey, it worked, great, here's the stream you just wrote to. All right, now let's create our update function that actually works with these messages. So update will receive the message, it will receive the current state of our model, and it will return a record which has an updated model and another command we can run if we want to. So when that message is asked for name, it will hold either an error or some kind of success. So okay is so a result will give you either an okay value holding the thing that you wanted, or an error value holding the error. Okay, so when it succeeds, for now, let's just do nothing. We'll say, go ahead and just return the same model, no command. We'll come back to that. But what if it fails? That's a little bit more interesting. Let's figure that out. So I don't think we need to, pretty much, I think for all of these, we're not going to be changing the model. But if it fails, let's quit the program with a proper status message. So with a proper status code. But first, let's try to send something to standard error, just an error message. You know, I doubt if standard out is working, the standard error is working. In which case, instead of using stream.writeLine as bytes or whatever else, because then you might end up in an endless loop, right? Like what if writing to standard error fails? Well, we do another error handle, and this time we don't write. It's just a little overcomplicated. So there's a module called stream.log. Where's that? It's in core. Yeah, there it is. So it does basically just a best effort write to a stream. And if it fails, it lets you ignore it. So if we can write to standard error, we will. So what did we want? We wanted stream.log.line. That's similar to write line as bytes or whatever we called earlier. I don't remember. And we'll say failed to write output. And then we want to set the status code. So instead of exiting with a 0 meaning success, we want to exit with let's exit with a 1 to indicate that there was a problem. And stream, this gives us a task. Setting a status code is another task. So we can chain tasks together like this. We can say task that and then, and give it a function. That function will get the result of the previous task, which in this case we don't actually care about. So we'll just leave it as an underscore. And the task we want to tack on here is, I think it's set status code. We'll see. And we'll just end it there. That should end the program. And our subscriptions is the last thing we need to write. It will take an instance of our model and return a subscription, which in this case, I don't think we need any subscriptions. So we'll just say sub.none. That might be enough to run this program. Let's see. So where are we? We're in this folder. And the new version of Gren, so I'm on 0.6.2, has this run command. And you can just give it a module name. In our case, it's main. And it will compile and run the module for you. All right, we've got some errors. So I did not want status code. I wanted exit code. Okay. Exit code. And stream.log.line, I did not import stream.log. Now what? Okay. Update says it should be a command, but I returned a task. Oh, right. So this is still not a command. We changed two tasks together. That gives us a new task, but it's still a task. Now we don't actually care about the result of this task. I mean, we're doing a best effort here to wait. Nope, this is the wrong thing. What is here? I'm in the wrong place. Here it is. Here's the one that we chained together. Here is where we don't care about the result of this. We're just making a best effort to show that something failed. And the error type for both this function and this function, there's no concrete error type that we have to deal with. So we can do a function in the task module called execute. And that just says, hey, send the command, run it, and then don't do anything. In which case our program will exit, which is what we want. All right, what's your name? Now let's do something with that name. That's up here. So if it works, I I still think we don't care about the result value here. That's just the stream we just wrote to. Now, once we ask for the name, we want to read a value. We want to let them type in their name. So that means we need to read from standard in. Let's look at the stream functions again. Let's see, in core, stream, readable streams. All right, read bytes as string, I think is what we want because it's a readable stream of bytes, but we're gonna want a string value. Again, we're gonna end up with a task that we'll have to account for the error. Read, what was that? Read bytes as string, read bytes as string. I apologize, it's very early when I'm recording this right now. And what does it want? It wants the stream. So we saved that and standard in. All right, similar to when we wrote to standard out, we will need to turn that task into a command and it can fail. So we want task.attempt and we'll say got name. So we asked for the name. We have a message ask for name. We're gonna make a new message got name. Let's go ahead and do that. It's going to be a result, which could fail with a stream error. And it should, I think, just return the same string. Nope, this one's actually, it returns a string. That's good. That's what we want. All right, let's handle those things. Got name. So it'll either be an OK value holding the name that we want, or it will be an error. Similar to this, we'll probably just do the same thing here. We'll say failed to read input. I'm not super familiar with exit codes. I think we want different codes for different types of errors, or maybe any kind of standard IO error should be the same exit code. I'm not going to worry about that right now, but we'll go ahead and set it to, all I know is non-zero means bad. Okay, our model is the same. So now that we have a name, we want to say hello to that person whose name we just got. So we are going to, so again, we're gonna write to the standard out, but this is gonna be the last thing we do. So if it fails, it fails, who cares? And this video is getting long, so I'm gonna go ahead and just use stream.log again, which ignores errors. In a real program, you're probably gonna wanna do something similar to what we did here, where you're actually interacting with the stream in a way that acknowledges that it can fail and then dealing with the failure. But to close out this video, let's just use stream.log and say that we're writing to standard out. And we'll say, hello, name. And like I did up above, if it fails, who cares? We're just going to say task.execute. Actually, if it could fail, we won't be allowed to use execute. The compiler will complain at us, but in which case stream.log is ignoring the error for us. So by the time we get this task, it can't fail. The task can't fail. So task.execute will work. Should work. Let's see. I think I wrote this program correctly. Hey, what's your name? All right, now it's waiting for me to type something. So I'm going to say my name is Justin. Hello, oh, look at that. Hello, Justin, but it picked up the new line from reading standard input when I hit enter. So let's clean that up. Let's say that the response is hello, and then we trim that string to get rid of surrounding white space. Then we put the exclamation point. And now we can just print out that response. Now when I do it, there we go. Hello, Justin. Cool. So that is the very, very basics of standard I/O. There's all sorts of stuff in the core package for working with strings, working with tasks. Take a look, and I'll see you in the next video.